Welcome to Statistics in Sweats. I'm your host, your teacher, Miss Harrington. I wanted to make a video, and I'm hoping to make a video for you guys every week. Just kind of going over the information you need to know, because I don't personally believe that you can learn math on your own. Crazy thought. I want to go over the 2 assignments I gave you this week. Just hopefully a quick video, but the way that I talk, it's probably going to be really long. Who knows? Okay. Let's start with experimental review. So I asked you, what were the 3 principles of experimental design? And they are this. You need to have a control and an experimental group. You need to randomize, so randomize your participants. Don't just pick your friends or pick what's convenient. And then last, I don't know if you can see it. Yes, you can. It says use large groups. 100 is not really large. You kind of want to go in the thousands if that's possible. So depending on what type of experiment you're doing, just know that those are the 3. So if you haven't submitted the assignment yet, there you go, there's a 3. If you did submit the assignment and you put 3 things down, cool, awesome. After that, I asked you what's bias. And bias is kind of the idea that information is going to be skewed one way or the other, sometimes intentionally, sometimes not intentionally. And the 2 types of sampling bias that cause that, and I should have had this written down already, and hopefully you remember, and if not, it's totally okay. But the 2 types of sampling that we talked about is voluntary and convenience. So voluntary is when people choose to participate. So if I posted an Instagram poll saying, what should the title of my statistics video be called? And 1 person voted and said statistics in sweats. That didn't happen, but I was the voter. You didn't have to participate. It was voluntary. Convenience is the idea that I have a question and I'm just going to ask the people around me, which would be Kirk, and say, hey, what should this be called? And he would say, not statistics and sweats. That is convenient sampling because it's whatever is convenient for you, usually the closest or the first 10 or the first 100 or just sampling music videos, something that would be convenient. Okay, using random selection. So what we are used to doing is we are used to going in the calculator and going math, probability, random integer 1 to 100, and just kind of hitting this button. Random integer, keep hitting enter, and just getting a new one. Remember, we don't want any repeats. A stratified random sample is when, instead of just labeling people 1 to 100, maybe I'm going to group them by their gender or by their race or by their occupation or even by height. It could be anything. I would group them by that, and then I would pick an even amount from each group, and that's a stratified random sample. We used that random integer chart. I don't think I'm going to be asking you anything like that because 1, it would require you to have a calculator. 2, it would require you to have the chart, and that's a pain in the butt to use online. That's that. Data ethics. And there are 3 basic standards of data ethics, and they are these. It needs to be approved by an institutional review board. All participants need to have informed consent. And last but not least, it needs to be confidential. So you can't give out information. You can't say, Miss Harrington is this blood type. You could say something 50% of the participants had this blood type. You can give percentages and kind of group them, but you can't give out specific data based on people and their names. That's it for the experimental review. Now I want to jump into probability. So the probability questions I gave you deal with independent versus dependent. Independent is when the first event does not affect the outcome of the second event. So if it's just one event, it's It's not even a compound event, and you don't have to worry about that. But if it's 2 events back to back, such as flipping a coin, like if I flip a coin, then flip a coin again, that'd be a compound event. And coin flipping, actually 2 things are always, always, always independent. Coins and die. Well, dice, whatever. Those are always independent because it doesn't matter if I get heads 5 times in a row. The 6th time, I could get heads. And it doesn't matter if I roll a 4 5 times in a row. I could get 4 again. We usually see dependent with a deck of cards or like I have a bag of marbles, which was on your assignment. When you keep it, it means that the denominator is now changing. So the denominator is like how many possibilities there are. So in a deck of cards, the denominator should be 52 because there's 52 cards in a deck. No, we don't include jokers. In the marble example I gave you on your assignment, it was 10. And I didn't want to use color, so I just did shapes. So there are 10 shapes here. We're going to do a couple problems with that. But before I ramble too much, I'm just going to go over really basic and then work our way up to the marbles and then the die. Not the die, the deck of cards. So if I were to ask, what's the probability of flipping heads, then flipping heads, then tells us we need to multiply. So the probability of flipping heads is 1/2. Then another half, because heads is 1/2, tails is 1/2. I want you to get in the habit of using fractions because it's going to make it a trillion times easier than using decimals. So I have a 1 out of 2 chance of getting heads, then a 1 out of 2 chance of getting heads. And then we just multiply our fractions. So with multiplying fractions, you multiply the top, you multiply the bottom, and I have a 1/4 chance of getting heads, then getting heads. So that's what I'm looking for with that. Let's go into dice. So I roll one die. And what's the probability of rolling a 1? So there's only one number 1. That's why it's 1 out of 6. Not because I'm rolling a 1, but because there's only one 1. Then I roll a 6. This is not 6 out of 6. There aren't 6 sixes. There's only 1 6. So 1 times 1 is... Ooh, that's ugly. And then 6 times 6 is 36, so I have a disgusting 1 on top of a 36. So I have a 1 in 36 chance of rolling a 1, then a 6. That seems pretty easy, and hopefully it is. If not, let me know. But let's jump into something that requires you to think a little bit more. So what are the chances that I roll an even number, and then I take a coin, and I flip it and get tails? So there are 3 even numbers on a die. 2, 4, 6. 3 out of 6. There's 2 ways you can do this, and I'm going to show you both ways. So you have a 3 out of 6 chance of rolling an even number. And then to flip and get tails, it's 1/2. Now you can do it this way, and just multiply across and get 3 out of 12 and have a fraction that you definitely know you can simplify. And you can simplify it, divide the top and the bottom by 3, and get 1/4. Or, from the jump, you can simplify this. So I know 3 out of 6 is the same as 1/2 because 3 divided by 3 is 1. And 6 divided by 3 is 2. I can't simplify 1/2. Remember, that's our tails. And I get 1/4 either way. So it's up to you, however you want to do it. I don't even care if you simplify, to be honest. If you were to get here, I'm a happy camper. I think it looks prettier to simplify it, because it does. But either way, any method, it makes me happy. Okay, that's all independent. The roll had no effect on the flip had no effect on the roll, the flip had no effect on the next flip, and the roll had no effect on the next roll. So I'm going to go into my fancy, very high-tech bag of shapes. I have 4 squares, 3 circles, 2 triangles, and 1 hexagon. So here I have 10 shapes, because 10's easy to work with. Let's say we wanted to find the probability of a square, then a square, keep it, then a circle. So if I pick a square, I have a 4 out of 10 chance. So let's write that down. I'll show you the simplified version later, but let's just do it a step at a time. So 4 out of 10 chance of getting a square. But if I keep the square, I no longer have 10. I have 9. So my next probability, it said square then circle, it's going to be 3 out of 9, because there are 3 circles and 9 total. Cool. If you are like me, and this looks gross to you because your gut's telling you, simplify, 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 then let's simplify. 4 out of 10 turns into 2/5. 3/9 turns into 1/3, and we multiply across. If, for some reason, you feel like you would screw up by simplifying, cool, I don't care. Multiply the top, multiply the bottom, and 12/90ths is still the same thing as 2/15ths. Both of these make me happy. I'm A-okay with either. The important thing I want you to remember is that by keeping the square, we are forcing it to be a dependent compound event. The first event affected the second event. It made it go from 10 shapes to 9 shapes. We could have an independent event with this bag of shapes, and that's A-okay too. Let's say we're doing a circle. We replace it, and that's the verbiage I'm going to use. I'm always going to say replace. And replace doesn't mean like let me go run out and get something else and put it back in. Replace just legitimately means put it back in. So let's do circle, replace, then hexagon. So back to my bag of shapes. I have 3 circles out of 10 total. So I'm going to do 3 over 10. I put the circle back in, so now there's still 10. This is an independent event. And then I want a hexagon. There's 1 hexagon, so it would be 1 out of 10. I don't need to simplify anything. I don't have to simplify anything. So I'm going to do 3 times 1 is 3, and 10 times 10 is 100. And I have a 3 out of 100 chance of getting a circle, replacing, then getting a hexagon. Let's do another dependent event. I have 2 more things to go over, and then I'm done rambling. But yeah, so let's do another dependent event, and I want to go back to squares. I think I'm just a little biased towards squares. So, if you need to see it again, let's do square, keep, then square. And this is where the dependent can affect the numerator as well. So I have 4 squares. So the chance of grabbing a square, 4 out of 10. And again, we're going to simplify later. Don't worry about that. So a square. Boom, 4 out of 10. Now what happens here is because I'm keeping the square, not only is there no longer 10 objects, but there's only 3 squares. So this now turns into, for square, 3 out of 9. And you'll notice the same thing kind of happens when we did square then circle. I can simplify this because my insides are saying you need to simplify this now. So I'm going to do that. And then I can simplify 3/9 to 1/3, I get 2/15, and then up here, I can get 12/90. And again, I don't care. I don't care which one you decide is better. This is the one that SAT is going to want because SAT and AP tests and anything official is going to want the simplified version. But considering the circumstances, if you get here, I'm fine with that. Last but not least is kind of a tricky one. But if you trust your gut, you just know automatically what it's supposed to be. So I gave you a question like this on your worksheet, and I don't know if it tripped you up or not. So let's say, what are the chances of grabbing a hexagon, keeping it, and then grabbing a hexagon? So one of two things can happen. You can do this mathematically, or you can look at this and say, there is no way that I could grab a hexagon, poof, gone, and then grab another hexagon. You could stop right there and say 0, which means impossible, or I can show you mathematically how this is done. You can use your brain and be like, there's only one hexagon, you're beat. Or you can say, I have a 1 out of 10 chance of getting a hexagon. I keep it, so now there's only 9 left, and there's 0 hexagons left. 1 times 0 is 0, 10 times 9 is 90, but 0 over anything is 0. So don't let that question trip you up. I gave it to you on purpose. I wanted to see if you would get tripped up. I wanted to see if you'd trust your gut. Thank you for watching the full 17 minutes of me rambling and trying to catch you up on things. If you have any questions, you know where to reach me. We can set up a Google Meet if you want to do that as well. Just email me. Hopefully I will have this up before 5 o'clock. If you have to submit something late, don't worry about it. I hope that this helped. I guess subscribe, hit the bell notification. I don't know what the cool kids say. But I'm done. Thank you for watching, and I miss you guys, and I hope to see you. Well, you're seniors. I won't see you next year, but hopefully we can do something for you guys. I know that graduation is not going to be what you expected, but I miss you. Please know that, and I hope that I can see you guys at some point to celebrate the seniors of 2020. So, bye guys!